let's go ahead and get started. So, I am Matt Heon. I've been at Red Hat for 10 years, and I am on the containers team. Been working on Podman for the last 8 years since the project's inception. And this talk was originally by Mario Laureato, one of my coworkers. Unfortunately, he couldn't make it today, so I'll be giving it in his place. Now, this is done using something called present term, which means I'm going to have some live demos in the slides. Unfortunately, it also means I cannot easily adjust text size. So when I'm doing text slides, there will be some very small text. Sorry about that. Fortunately, there's very little text. This will be mostly demos. So let's have a brief look at the agenda here before we kick on to Podman itself. I think most people are probably familiar with it, but a bit more on the project. Podman started off in 2017. We made our first releases in 2018. It runs containers on Linux natively. We also have the ability to run them on Mac and Windows via virtual machines. And we recently, as of, I believe, December or January, were accepted into the CNCF sandbox. So we are now no longer a Red Hat project. This is a donated community project. And currently we are on version 5.5.1. And just a brief demo of how Podman works, showing off how the demos are going to work for the rest of this. Here we go. We have a simple Podman run command starting a container. 8080 for the port gets us a working web server. And there we go. So now let's talk about Podman and Kubernetes and why we went in this direction. So we're going to wind the clock back about 6 years to call it 2019. And Podman has just gone 1.0. We are finally released. We're calling people that we're stable. However, we still were not doing everything Docker did. And one of the big gaps that we had was Docker Compose. A lot of people like Compose. It's a very easy, very simple way of spinning up multi-container deployments. The problem is that it requires a full copy of the Docker HTTP API. Podman 1.0 didn't do that. We did not include API support until 2. At the time we did this, we were not even planning this. This was not in our wildest dreams. We wanted to restrict ourselves to just CLI compatibility. So we are looking for a way to provide a Docker Compose-like experience while at the same time being unique and differentiating ourselves. Just being a pure clone of Docker won't get us anywhere. We want to do something unique, something they don't do. And one of the first things that came up was, why don't we do something Compose-like, but using Kubernetes YAML? Kubernetes YAML is relatively standardized in the sense that Kubernetes is giant enough that anything it does can almost be considered a standard. And it provides a number of uses that you don't get out of standard Compose. One, you can pretty easily take something that you've written for Podman and Kubernetes YAML and just run it on a big cluster. So if you are doing, say, a single node deployment using Podman and you've decided to manage all your things using Kubernetes YAML, and then you decide you're going to scale up a bit, well, now you can deploy all your stuff to the cluster using that same YAML. Or let's say you're a developer and you have your big cluster out there and something you're running in it isn't working. Now you can run that same YAML locally, you can debug it. Basically, when we looked at this, it seemed like it was a logical way to create an alternative to Compose and do the same things they could in general, but also provide better interoperability with Kubernetes, OpenShift, etc. So, a core component of how we are able to do this is that Podman does pods. We have since the very beginning, and here's a brief demo of how they work. So, a Podman pod associates, ports at the pod level. So here's just a brief creation of a pod. And then we're going to make 2 containers in the pod. Regrettably, it seems to be scrolling off the bottom of the screen. Okay, there we go. Hope the text is still vaguely visible at least. And now let's go ahead and start this. So in a Podman pod, it's a group of containers that are treated together. It has a couple of additional properties. For example, we could find dependencies between these containers. That start is actually graph-based, so we can start in various orders based on what the user has defined. And here we go, a very simple PS. You can see we have 3 containers up here. All of them are present in the same pod, and all of them are running. However, if you look at these 2 Podman creates right here, you will notice that there are only 2. Why do we have 3 containers? The answer is that we have an inference container. There is a 3rd container that is sitting there running what we call a pause image that effectively does nothing. Its purpose is to hold open the pod namespaces. So in a pod, we are sharing a couple things. We share the network between all containers in the pod. We're sharing several, IPC namespaces, so we can talk to various other containers in the pod using things like Unix shared pipes, name pipes rather, things of that nature. So DevSHM is shared between everything. And also, we are sharing mounts between things in the pod. So you can have, any container in the pod access any mount that's added to it. And just get rid of it. So pods stop all containers together. Again, graph ordered, so we can guarantee that your dependencies don't break. You can order things so that if your DB container goes down, it goes down after the web container, things of that nature. And then removing moves together. Let's talk about Kubernetes YAML and how similar it is to what we just did. So this is effectively the same thing that I just did with those 2 Podman run commands and 1 Podman create, except it's a bit bigger, which is a natural property of YAML. You love it or hate it, it's very declarative. So let's just go through here. Here we have container number 1. This was the first Podman run. This is just running a simple Redis container with a simple database running in it. Most important thing, we've got a read-only root file system, and we have a single mount into it, which is based off a volume, a PVC. And we have a second container, which is just our simple actual server. It has a port defined. In Podman, you'll notice that we define the ports at the pod level, but that's really just an implementation detail. And here we go. We have a single volume, which is defined as a PVC. So we can map all of that into Podman pretty seamlessly. I just showed you how you do it without a Kubernetes YAML. Now let's run that simple YAML up there. And here we go. Now we are only ending up with 2 containers here because we are, oh yeah. So we're ending up with 3 containers, but our pause container does not have an image. This is actually very new. Should have thought of this before I updated to Podman 5.5. So in 5.5, we changed the pause container to just basically it mounts from the host instead of using an image. Anyways, that is the pause container. We have a Redis container, and we have a localhost container, which is based off an image that I've built. And like I said, we had a PVC in that Kubernetes YAML, and here we go. It's created a volume. And if we do a curl, we have a very simple web app in there that you can see just running a counter, database backed. So now let's talk about what we did to make this better. So the ability to run Kubernetes YAML, obviously very useful. What can we do to make this even better? One of the big things was we wanted to be a compose replacement, and compose lets you do some interesting things, like define containers by a Docker file, not by just an image that's available on a registry. So let's go ahead and remove that image that I built before, and let's say that we're going to build that image. So here you can see that it's building. And how is it doing that? I'll show after, but we have a local copy of a Docker file in the same directory I'm running this. So actually, you can see right here, this is the directory I'm running this out of, and we should have a, it's in, Docker file right there. So when we run the Kubernetes YAML, it looks for the appropriate Docker file and the appropriate directory, and it's building it. So this gets us the ability to act like Docker Compose in that sense. And then You can see right here, we removed the image before. Here it is. We have rebuilt it. And it is exactly the same as it was before. So we have the localhost image, that's the one we built, and then we've got the Alpine image, which we didn't need to, didn't have a build defined for that. So yeah, we can mix and match between images we want to build locally and images that we don't, images that we just want to pull. Volume LS, exactly the same. And again, we have a working web app. So let's talk about kube generate. So running the YAML is useful. What else can we do with it? What if we could take a simple container like this? This is a bit simpler than the previous 2 container example I had, but here we go. We're running a container simple HTTP image. Generate kube, which I've just run, is going to take that and make some Kubernetes YAML out of it. We've got a simple comment at the top. This is the version we made it with. This is what you should do to actually apply it to a cluster. But here we go. We've taken all the elements of that container. The most notable one was that port. That's made it in here. We've taken the name because we don't really know if the user specified a name or not. So we will put the name in. I recommend that you edit it. We have to do, one of the downsides of this is that the rules for how Podman names containers and the rules for how Kubernetes names containers are not exactly identical. We allow some things that they don't. So there are some interesting things happening when you try and name, say, a Kubernetes pod the same as a Kubernetes container. That's perfectly legal. Podman doesn't allow that. So basically what I'm saying is we have to do a bit of escaping here. You will occasionally end up with some downright unreadable names. But again, all we're doing is outputting this YAML for you. There's nothing saying that you can't take our horribly unreadable names and make them actually readable. And kube generate has some other interesting properties in that you can actually generate some things that are not in, Kubernetes itself. So this right here is a container with a ulimit. Now the ulimit kept has been stuck in nothing land for I think 6 years at this point. You cannot do any sort of ulimits in Kubernetes right now. Which means that if we want to take this and we want to be able to pull it into another Podman instance and do a Podman play kube on it and have it actually work, we have to store that ulimit, which is not recognized anywhere in Kubernetes, somewhere. And the solution we've run for this is annotations. So we have a IOPodman annotation ulimit, no file equals 1024, 1024. That means that PlayKube is capable of doing things that ordinary Kubernetes cannot. And the big use case for this is, again, our compose alternative case. So when we take something, if you make a complex Podman container, something that Kubernetes cannot represent, you still want to be able to use it again. You still want it, if you generate kube on it, you want to be able to run it elsewhere. And just an example of this, let's generate to a file, remove the existing container, and then let's play. And the result of that, if we do a quick inspect, is the end proc limit is always there. That's added by Podman as default, but that 1024 no file limit has survived. So generate kube and play kube are meant to be paired. Anything that a normal Podman container can do should be able to be taken through generate kube and run through play kube again, and it'll just work, even if it's not supported. And then what I think is one of the cooler demos here. Here I have a Docker Compose YAML. Now, as of version 2.0, a while back, we now have support for Compose by targeting the Docker REST API. So this is, you can see right here, running external Compose provider. Yeah, so this is actually running Docker Compose from my home directory. And we've started up a couple containers from this absolutely trivial YAML. And here we go. So I have taken the compose file and I've generated a considerably more complex, but mostly equivalent Kubernetes YAML off of it through one command. Now, we don't guarantee this is going to be perfect, especially for multi-container deployments. Like I said, one of the big things you will find is that if you use a generate kube, we're probably going to rename some of your containers. And if you're running a compose file, it probably is assuming that you have access to other containers by their names. You change those names, things are going to break. So I don't promise that if you take your favorite compose and do this, it's going to work perfectly. I promise that it will get you 90% of the way there. And then from there, you will have a bit of debugging. You'll probably identify that I need to set an environment variable that wasn't set. I need to rename this in one of my configs. But it will get you almost all the way there. And now let's see, in this case, what happens if we... So, running from Docker compose. Oh, okay, the demo gods have cursed me. It's a 403. Oh well. Close enough. And now we're going to generate kube to a YAML. We're going to remove the existing containers that I just made from compose. And we're going to do a play on that. And here you can see that we've made 2 containers. That was a very simple compose YAML again. So we've just got our infra container, as I explained, and 1 single application container. And while the demo gods have still cursed me, at the very least, it's the same error both places. So, what do we support out of Kubernetes? The answer is quite a lot, but not everything. Pods were the first thing that we did, and obviously, if we have a pod concept in Podman, not that hard to map it into Kubernetes, and vice versa. Deployments came later, mostly because people kept asking us for them. Deployments are a way of grouping multiple pods together. We don't do replicas by default because Podman, again, single node only. If you want to do 5 replicas of a DB container on your single node, there's a command line flag to podman play kube that will let you do this, but we aren't going to do it by default because replicas only really make sense if you can spread them across multiple nodes. Next, persistent volume claims. Obviously, if you want to get most types of volumes, we'll be able to do that. There are a couple particularly esoteric ones, I believe, S3 back volumes, for example, that we cannot do by default, but most of the Kubernetes volume types are implemented. ConfigMaps. This one was a community PR, actually. We get a lot of community attention on generate kube, play kube. These are used a lot out in the wild, and we are very appreciative of the fact that people keep expanding them. But anyways, ConfigMaps give you a lot of ability to define configuration terms, and we will quite happily use them. Secrets, this came in with the Podman secrets driver, I want to say 2 years ago. And daemon sets. So one of the big things that we are not going to do is ingress-egress objects and more complicated networking. Again, Podman is single node only, so a lot of the more complex Kubernetes networking concepts don't really translate. We've discussed in detail how we could think about doing it, but it has never ended up being particularly feasible. We always felt like the experience we'd be delivering just didn't make sense. So if you have ideas as to how we can make this work, we'd love to hear them. But unfortunately, it's just not something we can really do at the moment in a way that actually delivers the experience you'd expect. Oh, I forgot jobs. We do jobs too. All right, and then just a brief preview of a couple other things that we do with Podman. We are rootless and we are daemonless. This is especially relevant to people who are on edge use cases. We don't have any additional resource utilization because Podman just goes away after you start the container. And rootless especially is good for security. It means that you aren't going to have, even if you pervesc, you're not going to be root, which is very useful. Or container skip, not pervesc rather. Build farms. So we have recently added the ability to take a bunch of additional systems and basically move your builds out to them. This is mostly relevant for the multi-arch build case. So if I have, say, 5 architectures I want to build for, AMD 64, ARM 64, and the 3 IBM ones, well, we can just take that. We can have a builder for each. The build farm command allows you to take the same build and distribute it out to all of those systems. And once all the builds are done, automatically takes them, packages them up into a single manifest list. Very easy way of distributing multi-arch builds. Next up is image volumes. This is a way of taking an entire image and putting it into a container. So one of the big uses for this is security scanners. If you have a security scanner and you want to be scanning every image on the system, we can take an existing image, mount it into the container that the security scanner is in, and then just run the scanner with the exact same invocation repeatedly, because you know the image is always at, let's say, /data. And we're just going to keep running that over and over again, different images mounted in the same place. Quadlet. Quadlet is a very exciting new thing we're doing. This is systemd managed containers. If I knew I had 10 minutes, I would have added a demo for that. Anyways, Quadlet is an additional way of running containers and managing them through systemd. And it is a particularly useful one because if you know Docker run, you know it has something called ---- restart. Why should Podman be doing that if you have systemd? There's already a service manager on the system. Why shouldn't we be using it to control our life cycles? And Podman SH. This one I don't think gets enough love. It's actually relatively on the older side, but this is the ability to have users log into a container. So if someone SSHs into the system and Podman SH is enabled, we drop them into a container as opposed to a regular shell. That means we can strictly limit what they can do on the system, 1, but 2, if you log in, we can just delete that container afterwards. Any change you make to the system is now non-permanent. And here we go. A few resources on Podman and this slide deck, and I think we can move over to questions. Yes?
I have a question regarding the migration from Docker Compose to Podman Kube generate. How do you manage, if you manage it at all, the migration of volumes without actually losing the data that are within the volumes?
That is not done by default, but it's possible. We have commands called podman volume import and podman volume export. Okay. So the basic idea would be export the data to a tar file, which sucks because you've just duplicated everything, but is what it is. And then once you have created the new, Podman, basically you generate, you'd run, from there you know what the volume name is, import it into the volume once it's created.
So you basically create a new volume and then you import the data from the original volume and that's how it runs.
Exactly.
I see.
And if the names are the same, it will actually just work seamlessly. It's just that the names are almost never the same. So Compose really likes underscores. Kubernetes really doesn't like underscores.
I see. Thank you for the answer.
Any other questions?
You can do PVCs and you can do rollouts and deployments. Can you also do stateful sets?
No, we have talked about that. There's no reason we can't, but no one's implemented it yet.
Okay.
Feature request bulk. Also pull request bulk if you want to do it.
Are there more questions?
Okay, thank you everyone for coming.
Oh, sorry, there's one more.
Hi, thank you. Maybe I didn't catch it, but when you create a pod or maybe deployment from the Docker Compose, does it recreate the replicas count?
Does it work with what? Sorry?
If when you create a pod or perhaps deployment from the Docker Compose, does it recreate the replicas count?
Not by default, but you can edit it in if you want to. So the idea is that we will generate YAML that is close enough And from there, you will take it and take whatever changes are necessary to make it what it needs to work, one, but also two, if you want to add replicas there, it should also work.
Thank you.
Hi, I'm using Podman and different system unit files and put them in a network. So would you recommend to switch to a Kube or should I run it as it is, so without compose, so switch from the old classical, yeah.
So generally speaking, as a Podman developer, I would love it if you moved to Kube. It's the way we see it, it's the way forward. It's a lot more integrated with Podman. You get a better and more native experience, and that's not just me saying things. The Podman's replica of the Docker API is very good. It's rarely completely perfect. We are obviously working to fix things as we find them, but it's more buggy than you will find Generate and Play Kube are. So I would say it's a better experience, but if what you have is working, then you're probably not hitting the bugs. So you can stay and probably not have a problem.
If there are no more questions, please let's thank the speaker. And thank you very much for your time.